In this video, we're going to talk about Bayesian inference. Bayesian inference is a method of statistical inference in which we use Bayes' theorem. So if we get Bayes' theorem and replace A with theta, where theta stands for the parameters that we want to estimate, and B with data, which is the data that we have, we get this form where the probability of observing theta given the data is what we call the posterior distribution, which is what we want to estimate, and the probability of observing the data given theta is the likelihood of the data, and the probability of observing theta is our prior belief about the parameters. Finally, the probability of observing the data is the marginal distribution of the data, which is a fixed number, and that's why we often write this like that, which means that the posterior is proportional to the likelihood and the prior. This means that within the Bayesian estimation framework, we need to do two things. The first one is to define the likelihood of the data, okay, and also make an assumption for the underlying distribution that the observed data follow. And the second step is to specify some sort of prior information about the parameters that need to be estimated. And of course, again here, choose an appropriate distribution for the prior information. So what is the difference between classical and Bayesian modeling? In classical modeling, we use the data to fit a model and estimate the parameters of this modeling. While in Bayesian analysis, we add some prior information about these parameters, and this prior is then combined with the likelihood of the data in order to compute the posterior distribution for these parameters.